Okay, so consider the pattern task below. How are the squares growing? What do you see? We're doubling. Okay, so we're multiplying by 2 each time, right? Multiplying by 2 each time. So in order for us to figure out what a sub 8 is, what is going to be a sub 5? Well, we started off with 6, then we got 12, then we got 24, then we got 48. How do we figure out 5? How do we figure out 5? What is that going to give me? 96. All right, what about the next one? And then when the next one, say it again. 82. And then 764. So, is there another way to do this? Yeah, what would it be? 2 squared, what? Which one? 2a squared. Okay. So you're saying that there would be an equation, right? Okay, so today we're going to talk about what is that equation actually going to look like. Because, like, let's say we were trying to find a sub 100. That would take forever if we did it this way, right? So we definitely want to have an equation so that we don't have to sit here and calculate each one out. Okay. So we're going to write and use geometric sequences to model situations. Just a reminder, we learned about arithmetic sequences a couple months ago. All right, what do we know about arithmetic sequences? I will say nothing. Okay. When you're adding. Okay, so like for instance, if we have 13, 9, then 5, what are we doing? Okay, so we're subtracting 5, not 5. So we're subtracting 4 each time. We talked about the recursive formula, and then we talked about the explicit formula. Okay, so really quick, just a reminder, if you're given the recursive formula, this is what it looks like. I would write this down because like we haven't seen this in a while. If you're given the explicit formula, this is what it looks like. Okay, this is for arithmetic. This is if we're adding or subtracting each time. Okay, so how do we figure out what a sub 4 is? You told me we're going down by 4, right? So what's 5 minus 4? 1. So we're going to take 13 and subtract 4 3 times. Everybody see it? Okay. So, the new thing, geometric sequences. So arithmetic was adding and subtracting. Geometric is going to be multiplying. So each time on that first one that we talked about was multiplying by 2. So that's what we're going to call a common ratio. So last time we had a common difference. This time we're going to have a common ratio. So our common ratio is 2. Good. Like I said, this is the easy stuff. You got to pay attention though. Okay. We're going to write out the recursive and the explicit formula. You're writing this on your paper. Ready? So the recursive is going to be a sub n equals a sub n minus 1 times r. And you're going to state what a sub 1 is. The explicit is going to be a sub n equals a sub 1 times r raised to the n minus 1. All we're going to do is we're going to plug in what a sub 1 is and what r is for the recursive. And keep everything else the same. So you told me that we're multiplying by 2. And our first term is 6. We're going to do the exact same thing for the explicit. We're going to keep everything else the same, but our first term was 6, our rate was 2, and then we're going to raise it to the n minus 1. So a computer virus infects files very, very quickly. The number of files infected triples every minute. After the first minute, the 5 files are infected. Write a geometric sequence that models this relationship. So how much did we start with? How many files did we start with for the first minute? 5. Okay, so we're going to start with 5. And then it says it triples. What are we going to do? Multiply by 3. So 5 times 3 is 15. 15 times 3 is 45. 45 times 3 is 20 something. Oh, okay. But we could keep going, right? So what's the common ratio? What are we multiplying by? 3. Easy enough so far. Okay. Looking at the next part, it says write a recursive formula and write an explicit formula. So what I want you to do is I want you to take a moment. I put the formulas up on the board and you should have probably written them down earlier. Okay, go ahead and see if you can fill in the recursive and the explicit. Okay, write the recursive formula. So that's going to be a sub 1. Well, how much do we start with? 5 files. A sub n equals a sub n minus 1 times, what is our r? 3. You keep all that junk the same except for your a sub 1 and your r. That's all you plug in for both of these formulas. On the next one, for the explicit, we're going to say a sub n equals a sub 1, which was 5 times 3 raised to the n minus 1. That's it. Nothing crazy. Now, let's say that I wanted to find like the 17th term. Okay? I'm sorry, let's do the 10th. Let's make it realistic. Let's do the 10th term. I would plug in 10 into this equation. Plug it into my calculator, and boom, that would be my answer, right? So if I said I wanted to find the 10th term, I'd plug 10 into the equation. Cool? Okay, so I'm gonna give you a sticky. I want you. Okay, so what does this 1.05 mean in context? What does it mean in context? Yep. How much is salary? Okay, so how much your salary is increasing per year, right? 1.05 is the rate of increase in salary. Okay. Now, what does the 78,750 represent in context? We are awake. 78,750 mean in context. Say words again. What? Well, she's getting an increase each year, right? So her initial value, right? Let's just, so we got initial amount salary. Okay. Now find the explicit formula. Okay. So remember, explicit is a sub n equals a sub 1 times r raised to n minus 1. Somebody just asked me, what does the a sub n mean? A sub n is what we're talking about currently. Like, if I wanted to find the 8th year, I would say a sub 8. Okay, so this is just the equation, right? So we're going to say a sub n equals, what's our first term? How much did we start with? 78,750. And then what was our rate? 1.05. And we're going to raise it to the n minus 1. So you're determining if it's geometric. And then you're going to tell me what the ratio is, what the 8th term is, and finding the explicit formula. And you're going to do that for 11, 12, 13, 14, 15, 16. Okay. I'm going to call a couple of y'all up. We're just going to have a conversation. When you come up, you're just going to bring your paper with you and a pencil. Okay, so go ahead and get started on that. We're going to take about 10 minutes to get these done. So, go ahead. Okay, so checking your work on that. You should have gotten these as your answers. Okay. On the front with your word problem, the first one is arithmetic. The second one is geometric. Okay. If you forgot the explicit formula for arithmetic and geometric, you can look up on the board. I went and gave it to you. Okay. This unit, we're not going to deal a whole lot with arithmetic. We're going to be really focusing on geometric just because it's related to to exponential functions. But it is a thing you'll see pop up. Okay. All right, we're gonna go ahead and jump to our second set of notes. We're doing this just so we can go ahead and start talking about these things. So go ahead and locate those notes. If you didn't grab them, you can go over here and grab them from the desk. This is the stuff that I feel like is a little tricky, so I would pay attention to this stuff. Okay, so geometric sequences can be easy. You're really good at sequences. This is the stuff that takes a little bit more effort. Okay, so if you haven't been paying attention, now's the moment. Okay, so on here, we're trying to solve for x. If you are given Desmos, instead of doing this by hand, plug it into your graphing calculator, and wherever it crosses on the x-axis, that's your solution. But if you're not given a graphing calculator, like let's say on your mastery check, then what you need to do is you got to solve for x. So 2 to what power would give us 64? Okay, so you're going to sit there in your calculator. Is it 2 to the 8th power? Is it 2 to the 4th power? You tell me. Type it into your calculator. Okay to try a couple of times. Okay, so 2 to the 6th power would give us 64. That means that x equals 6. Let me see how I get that. And it's trial and error. It's literally like typing in your calculator. 2 to the whatever, okay? So 5 to what power would give us 125? Plus. 5 to what power would give us 125? 3. So x is going to equal 3. Can you try number 3? Okay, so 4 to what power would give us 64? 4 to the 3rd power. So look at this really quick. We got 4 to the 3rd and 4 to the x. Now, since the bases, this is called a base, okay? Now that the bases are the same, we can set the exponents equal to each other. That's why x equals 3. Does that make sense? Simple enough, right? Okay, cool. All right, let's take it up a notch. Okay. Here's a word problem. Yay, word problem. So suppose a scientist is measuring a bacteria population. The initial population is represented by B sub 0. Okay, so they don't give us an amount, they give us a variable, or they give us like a letter, right? And it has been doubling every hour. Create an equation to represent this situation where T measures the time in hours since the scientists began measuring the population P of T. Write the equation. So we got P of T. What was our initial? B sub 0. Okay. And then we're going to have doubling. So that means that we're going to have 2 raised to the T power. Yeah. If you decide to go into the chemistry world or bio world, you'll deal a lot with B sub 0. That's initial population for various things. Okay. Suppose the initial population was 100. So instead of B sub 0, we're going to plug in 100. After how many hours will the population be? 3,200. So for our initial, we're going to plug in 100. And we're going to set it equal to 3,200. Okay, this is the part that you pay attention. Ready? Because it's about to get tricky. We want to solve for T. So the first thing that we're going to do is we're going to divide by 100. And that's going to give me 2 raised to the T power. What's 3,200 divided by 100? That's going to give us 32, right? So 2 to what power would give us 32? 2 to what power would give us 32? So 2 to the 5th power would give us 32. So that means at hour 5, we would have 3,200. Let me see how I did that. Got to be able to solve. Okay. Now, if you have a Desmos graphing calculator, you plug this bad boy into your Desmos graphing calculator, it tells you on the x-axis. Okay, it's going to cross at t equals 5 or x equals 5. If you don't, you got to do it by hand. Okay. So If I ask what was the population after 7 hours, I'm going to take my equation and I'm going to plug in 7. Take my equation, I'm going to plug in 7. What do you get? All you got to do is type it in your calculator. Did I get that? Okay. You got to make sure that you're paying attention to what is the question asking. If it's asking for population, then we're going to plug this number in. If it's asking for the number of hours, we're going to plug the population number in and then solve for t. Okay. All right, so go ahead and take a moment. In a game show, the players play multiple rounds to score points. The table below represents the points available for each round. Write an equation that represents the scenario. So what was our initial? Okay. What are we going up by each time? Multiply by 3. And we're going to raise it to the x. Okay, now I'm not going to do x minus 1 in the exponent because it's talking about a table. Okay. What is the anticipated number of points in round 8? So I'm going to take my equation. I'm going to raise it to the 8th power. Take a moment, type that in. That's a lot of points. 7.5. Anybody else get that? If you tell me the wrong number, it's going to stay that way. Okay. You got what? Okay, let's pick. I got 164025. So 164025. Yep. Okay. In which round are we going to have 6,075 points? That means that we're going to take our equation and it equal to 6075. So what's the first thing I'm going to do with this guy? Divide by what? 25. Divide by 25. Tell me what you get. So 6,075 divided by 25. And 3 to what power would give me 243? 3 to what power would give me 243? Okay, so at the 5th round, we're going to have 6,075 points. Do the equation, which is 320 times 4 raised to the t. We're going to divide by 320. What did you get when you did that? 64 is equal to 4 to the t. And then 4 raised to what power would give us 64? 3. So t would equal 3. Questions? Good so far, right? Okay, let's add a little bit of chaos. All right, so go ahead and take a look at that last sheet that you picked up. It says like solving exponentials, blah, 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 blah. Okay, this is the part that you're gonna need for your SAT, your Algebra 2, etc. So definitely want to pay attention there. Okay. Let me get off this really quick. So we're on this page, right? Okay. We talked about solving a little bit already, but if we have something like this, let's say, looking at number 2, we have the same base. If you have the same base, you're going to set the exponents equal to each other. Okay, so you see how there's a 3 on one side and a 3 on the other? Same base. So we're going to drop the base. We're going to set the exponents equal to each other. Now we're going to solve. So what would I do? We got 2x equals 3. We want x by itself. We're going to divide by 2. So x is going to equal 3 divided by 2, or 1.5. Good on that one. Okay. Now here's where it starts to get a little tricky. Looking at number 3, are the bases the same? No. Oh, but can I rewrite 9 in terms of 3? So like, for instance, can I say 3 to some power would give me 9? Yeah, what is that? 3 to the second, right? Oop, nope, take it. Okay, so what I did was I rewrote that 9 in terms of a base of 3. Now, are the bases the same? Yeah, I can drop the base and look only at the exponent. So this is going to be 2 times negative 3x is equal to 3. Why did I keep that 2? Well, because it's an exponent, right? And now I can solve these equations. So I'm going to multiply 2 times negative 3x. And then I'm going to divide by negative 6. So that gives me negative 1/2. Number 4 is a little weird, okay? Because we have 2 raised to something is equal to 1. I need you to remember that anything raised to the 0 power is 1. So right here, if I have a base of 2 here, I can rewrite that 1 as 2 to the 0 power. And now they have the same base. So we're going to set the exponents equal to each other. And now you're going to solve. So we're going to add 1, divide by 3. I'm sorry, I'm writing that halfway across the page. You see it? Okay, if you struggle with solving equations, you cannot hide in this unit, okay? You have to practice in order to get better at this stuff. It doesn't just miraculously get easy, okay? Number 5 is probably as tricky as they really get. Okay? So, really quick, can I raise 16 to some power and get 32? Don't say no. Or I'm sorry, don't say yes. Okay? 16 to some power cannot give me 32. But we can use a number between 1 to 10 and rewrite these with a different base. For instance, 2 to what power would give me 16? 2 to what power? 4. Okay? 2 to what power would give me 32? 2 to what power would give me 32? 5. Okay? Now the bases are the same. So we can drop the base and set them equal to each other and then solve. So this would give me negative 10x equals 4, divide by negative 10. So x is going to equal negative 2/5 if we simplify. You cannot hide and fake it till you make it on this one. You either know how to solve or you don't. Okay, it requires practice. You don't get to like just walk in and it magically happens. Can you try 6, 8, 9, and 10? 6, 8, 9, and 10. Try those out really quick. Okay, so if we have the same base right here and here, we're going to drop the base. Boom. Okay, and we're going to set the exponents equal to each other. This will make it a little weird. You want to get your variable on one side and your numbers on the other. So we're going to add 3r to the other side. And so this is going to give me 6r equals 0. If we divide by 6, that's going to give us r equals 0. So now on 8, our bases are not the same. We've got 5 raised to the 3n minus 2. And 5 raised to what power would give us 125? 3. Now the bases are the same. So we're going to drop the base, set the exponents equal to each other, and then solve. We'll add 2 to the other side, so that'll give us 3n equals 5. Divide by 3. So n will equal 5/3, or if you turn that into a decimal, that's okay. Cool. I want to hit 7 really quick. So this is, it looks crazy. It's not that bad. So eyes up on the board, because you're going to see this on Algebra 2, and you're going to see it on your SAT. So right here, we got this fraction, 1/9. Negative exponents make our numbers flip. So for instance, instead of writing it as 1/9, I'm going to write this guy as 9 to the negative first raised to the 2n. Okay. Now, can I raise 9 to a power to get 27? Can I raise 9 to some power to get 27? No. So I need to change this base to a smaller number. I can change this to 3 to the second power raised to the negative first is equal to 3 to what power would give me 27? 3 to the third power would give us 27 plus. Now we have the same bases. This is going to look like a hot mess for a second. We drop our base. 2 times -1 times 2n is going to give us -4n is equal to 3n. Again, that looks a little crazy. I get it. We move that 3n to the other side. And so that's going to give me -7n equals 0. Divide by -7n. So n is actually going to be 0 for this guy. Okay. Fractions are going to be thrown in probably on your final, just because it's a little crazy. Because I did -4 minus 3n, and that gave me -7n. I moved that 3n to the other side. Okay. This doesn't just happen naturally overnight. You have to practice. Okay. So what I'd like for you to do for the next couple of minutes, go ahead and finish 9, 10. Go ahead and do 11, 12. Okay. Go ahead and try 11, 12.